Hello, Vidya.
Hello.
Congratulations on being a finalist in the SCIA competition.
Thank you. It's a big honor.
Let's talk a little bit about this case study. It's all about a British multinational chemicals company and its rail needs. What was the situation? What was the challenge?
There were really three challenges that the customer wanted to solve. One was the ability to tell accurately when their rail cars would actually be delivered to their customers. The second one was the ability to understand when their customers use the product that was delivered so they can bring their rail cars back to them. And the third was a pretty unique situation where the material that they were delivering were being put into silos for use. And in some cases, because of the types of material they were using, they all looked the same. And they would put the wrong material grade in the wrong silo, which could cause potentially a lot of wastage because now you've got to redo the product, clean the silo, and the entire system.
So a serious challenge. And of course, chemicals company is a particularly sensitive operation from a regulatory and a safety standpoint too. So all of that has to be figured into the challenge.
All of that is part of the whole solution.
Yeah. So you need to ensure a constant flow of rail cars. You need to make sure you know when a rail car is empty, when it's available, when it's clean. That's a lot on your plate. Tell me about the solution.
The solution involved two really IoT aspects. One was
Internet of Things.
Internet of Things. One of them was a sensor that would tell us very accurately where the rail car was. The other one is a pretty unique sensor. It's a lock that can be opened through the cloud, and it doesn't have a key. So the combination of knowing where the rail car was, knowing what material it was, and only allowing the lock to open when the material matched the sales order that was given to the customer, would the entire solution work. The uniqueness in all of this was the fact that we're able to tell when it would be delivered, when it's empty or full, all just through location and behavior. And the key there is lots of data. We spent almost a year and a half looking at 600 rail cars and understanding how they move. And the interesting thing is the rail system today, unlike the road system, is not a continuous flow system. Freight is treated very differently than passenger traffic. So it's very unpredictable. They could take your particular rail car and hold it for a couple of days because of traffic patterns. We had to take all of that data and try and make it predictable. So then when we tell the customer that it would be delivered on a certain day and a certain time, that it was pretty close to it. Some numbers there. Before the solution was deployed, it could be anywhere between 2 to 7 days of a sort of spread in which the customer would say, I think it's going to be there. We got it under 12 hours, which is a pretty incredible milestone if one thinks about the amount of data that's being computed in the behavior of the rail car being delivered.
What was involved in implementation? How long did it take? What challenges did you encounter along the way?
The biggest challenge we encountered was operational. These are big rail cars, which means that only qualified people can climb on a rail car, can put a sensor on a rail car. So we simplified the whole solution by mounting the sensors using high power magnets. So there was no drilling, there was no screwing in. They were able to just climb on top of the rail car and mount these sensors with magnets. That reduced the operational time to under 10 minutes per rail car to be able to deploy these solutions. The other big challenge was the ability to collect data over time. These average trips of these rail cars could be anywhere from 15 to 30 days between delivery. So for us to collect a lot of data was taking up a lot of time. So what we did was on certain lanes, just say it was going from California to Texas, we would send multiple rail cars on the same route to catch multiple data points, to be able to then quicken the data collection and also be able to gather enough data to statistically extrapolate what we were looking to do.
And the data is flowing from the sensors. Is that the sole source of the data?
That is correct. As a company, we're focused on getting data from our own sensors. They're not proprietary, but they're sensors mounted on objects. So in this case, it's a rail car. The sensor is telling us two things. One is when it moves, And the second is its exact location within 4 meters.
Mm-hmm.
That enables us now to be able to start talking about the behavior of the train. So one interesting aspect of this is when will it arrive, the ETA.
Mm-hmm.
So we're able to tell where it stops, where it moves, and then build a pattern. The second thing is when it's actually delivered to the customer, we look to understand the behavior. So imagine I deliver a rail car. It sits for a little amount of time, maybe a day.
Yeah.
Then it moves. And then it sits again for a period of time. We use that behavior pattern to understand when the customer is actually using the product. So when I deliver the rail car, it sits. So we know it's full.
Mm-hmm.
When it moves, after sitting for a period of time, we go, oh, the customer is using the product because they're bringing the rail car into the factory
Mm-hmm.
and then they're unloading the product. And then it moves back out again. That behavior was helping us tell the customer that you've used the product and now the rail car is ready to come back. That was actually a decrease in about 2 weeks of idle time on average at the customer.
Mm-hmm.
So we're saving our customer almost 20 to 25 days of just idle time, of non-use of the rail car.
That's
Now,
huge.
if you look at that across an entire fleet of, say, 10,000 rail cars,
Mm-hmm.
that's a lot of idle days.
Wow.
And idle days are money.
And how long did it take to get to those benefits?
It took about, I'd say, 18 months
Yeah.
to get there. But it took about, of those 18 months, almost 8 to 9 months to actually come up with the solution.
Mhm.
Because this is a problem that's never been solved. Today, rail car traffic is very old school. It's used with RFID tags, and nobody's really paid attention to it. The reason why this is exciting to us is this enables a lot more people to start looking at rail in a more predictable manner, looking at that as a transport mechanism that can be used for all kinds of products, not just for very specialty chemicals or
Mhm.
sort of freight, if you will. What that also does, which is very exciting, is really reduce the carbon footprint. So the more you take off a truck, the more you put on intermodal, rail, or ship, you're really reducing the carbon footprint. So we got a lot of benefits out of this. Very direct ROI in fleet reduction because they just needed less rail cars to be able to fulfill the same demand.
Right.
They also were able to be far more efficient because they could be proactive with their customers and say, dear customer, you've used the product, can I get it back? And then turn that rail car around faster. The third piece in all of this, with the amount of knowledge that they had on how the customer uses it, they were able to get closer to say, predict the customer's order pattern.
Mhm.
So they were able to go back and actually understand when the next order would come from the customer
Great.
because I know you've used the product.
Historical information was cast forward into the
That's
projections. Incredible. Some great innovations there. Thank you so much, Vidya, for describing what Roambee did for this chemical manufacturer. And once again, congratulations as being a finalist in the Supply Chain Innovations Award here at CSCMP. Really
Thank you
appreciate
very
it.
much. We're very excited to hear the results, but just being nominated and being in the final group, very exciting. Thank you so much.
Thank you.